For page 1 of your notes/activity, I think you can do it based on everything we talked about in the slides, and the answer key is available for you. I'm going to move us ahead to the next section. I noticed that question 5 is not filled in for the answer key. Sketch the distribution of x. So here's what I would like you to do if a question like that comes up. Just draw a nice bump. Try to make it symmetric. Notice how badly I do. And then make a center line. Center line should be labeled mu. And then we can make tick marks 1, 2, 3, 1, 2, 3. And I'm not going to label them 1, 2, and 3. I would like to label them mu plus sigma, mu plus 2 sigma, and mu plus 3 sigma, which is maybe all I have space for here. And then on the other side, it would be mu minus sigma, mu minus 2 sigma, and mu minus 3 sigma. Okay. The probability that x is a specific number is 0 because x is a continuous random variable. So the odds of landing on one specific number is virtually 0 or just 0. The normal distribution is a continuous probability distribution, yes. And instead of using normal PDF, we'll use normal CDF. Yep, we saw that in the slides. And we find the probability that x falls in a given range of values. This does confuse me a little bit, like why is that on your calculator? I'm pretty sure that what that gives you is just the height of the curve at any given point, but we don't really need that information for anything. Okay, so carrying on here a little bit, if we were finding the area between A and B in this picture, then our lower bound is A and our upper bound is B. If we are finding the area in the left tail, I'll just write the words left tail right here. Then we use negative 1e99 for our lower bound and A for our upper bound. And it just takes a little getting used to, but I don't think this is that big of a deal. Right tail here. So when we have a right tail, then B is the lower bound and 1e99 is the upper bound. And again, this is what I mentioned before. That is just a really big negative number, and this is just a really big positive number. So these were the male and female height distributions that we looked at a little bit ago. And notice that the standard deviation for the females is a little bit bigger, and the standard deviation for males is a little bit lower. Other than that, hey wait, this is females and this is males. I get my X's and Y's mixed up. Yeah. Okay, so find the probability that y is between 61 and 63.8. So these are the females. Got our lower bound and our upper bound. And then we put in our mu and our sigma. So 34% of women have heights between 61 and 63.8 inches. And I do want you to be able to write a sentence explaining your answer on almost any problem, because there's always a story in statistics. All right, so then here, this is a question about male heights. The probability that x is less than, let me just zoom in on this a bit, That's the symbol for less than. Here I just say between. But here I say x is less than that, and I don't know why these dots are showing up. I guess it's trying to read what I'm saying. Okay, so lower than, that just means that we're in a left tail situation, so that's why having this little image up here is helpful. Negative 1e99 for the left end, 69.3 for the right end, or the upper bound, and then we just put in our mu and sigma for the female heights. Nope, male heights. Oh, it's 50%. Oh, we should have known that. We're just saying what's the probability that any male is below average, and it's exactly 50%. So I like questions like this because after you do it, you're like, I knew that. I could have figured that out without a calculator, but we confirmed our answer. So what is the probability that a female is taller than 63.8? Well, that's another 50% answer as well, because that is the mean. So we're basically saying anywhere from the mean to the tallest possible height, 50% of women.